Hi everyone! In this video I'm going to show you how to run a three-way interaction in R. Of course there's multiple ways of doing things in R, and so I think that this might be the easiest way, especially for groups who have chosen a continuous moderator. So first we'll load our packages. Everyone knows Haven is so that we can teach R how to import SPSS files. Tidyverse is for cleaning up and reshaping the data. And then there's a new package which we haven't used before called JTools. And we'll use JTools to run the three-way interaction. So we get the normal warning for the tidyverse. And if you don't like seeing those warnings in your notebook, you can just press play again, and the warnings will go away. Next, we'll read in our data set using the read_sav command. Now, for this to work, you've got to download the data and save it in the same spot that you've saved the notebook. So I've saved my notebook and the data on my desktop. And you need to save yours, those two documents, in the same location on your computer. It doesn't have to be the desktop, but it has to be like a folder that they are both saved in. And then I will press play. Over here, nothing happens, but you do see that the dataset's been loaded into the environment. And if we look at it, we can see all of our data. Everything's looking good. Once again, we have the problem of our independent variables are not coded in a useful way, and we need to recode them. And so we'll use this code here to recode our independent variables. And again, in R, it's a blessing and a curse that there are so many ways to do things. So this way, I'm starting to think might be the best way, just because it's easy to read out loud what is happening. So as you read this code out loud, it describes what is actually happening. So that's what I like about it. So there's nothing that's sort of a mystery about what this code is doing. So we start with dataset, and we send dataset to the mutate command. So mutate's going to add a new variable to dataset. And now we got to tell mutate how to add that new command. So we're saying, okay, create a new variable called told price. And this will indicate whether the participants read a scenario in which they were told the price of the item or not. And so create a new variable, told price, in cases when this variable equals 1, so that's the first yes variable, or this variable, that's the other yes variable, equals 1, I want told price to become told usual price. But in cases when price no equals 1, or the other price no equals 1, then I want told price to become not told usual price. And so that's all the code to make the new variable told price. Now let's make the new variable seller gender. So I just put a comma after that first line, and now we're talking about seller gender. So in seller gender, in cases when we have male equal 1 or male equal 1, seller gender should be male seller. Or in cases where we have female equal 1 or female equal 1, seller gender should become female seller. And then I want you to save all of that back into dataset. So after we run this little chunk of code, we should have two new variables in our dataset, one called told price and the other called seller gender. So let's see what happens. Now if I click on dataset and I scroll all the way to the right, I get my two new variables, told price and seller gender. Okay. The next step is going to be to make the independent variables, so in that case that's told price and seller gender, into effect codes instead of factors. So right now they're factors. Factors are what R calls variables like told price and seller gender that are, words, right? And so these are just the names of our conditions. They're not numbers. And so R calls them factors. But for our three-way interaction analysis, we're going to want to have numbers, not factors. And so what we can do is we can recode the factors into numbers. So what we'll do is we'll change told usual price to 1, not told usual price to -1. And that's called effect coding. So we're comparing the 1 level to the -1 level for the told price variable. We'll do the same thing for seller gender. We'll make male seller equal 1 and female seller equal -1. And that will be, and so we'll be comparing 1 versus -1 in our analyses. And again, you can read this code the same way as the code up above. So we start with dataset and we send it to the mutate command. And mutate adds new variables to the dataset. We're going to make a variable called told price effect code. And how we'll do it is, in cases when told price is told usual price, told price effect code will be 1. But in cases when told price equals not told usual price, told price effect code will be -1. And then we do the same thing for seller gender effect codes, and then we save it all back into dataset. So when we run this, dataset should now have 2 new variables. And if we scroll all the way to the right, we should be able to see them now. So we have our original independent variables that are factors, or just words. And then we have the effect codes, which are 1s and -1s. All right, and now we can do our 3-way interaction. And for this, we'll use the JTools functions, our function sum, and later we'll use probe interaction. But first, we're just going to use the LM function, so the linear model function. The way it works is we tell linear model what our dependent variable is, so I've chosen Q81. Then we tell LM what our independent variables are. So that's my first independent variable by my second independent variable by my third independent variable. Now, if you put pluses instead of asterisks here, then you don't get the interactions. So if you want to get the interactions, just put the asterisks. And then finally we tell LM which data set we're going to use, which is, of course, data set for us. And I save the output of this function that does the linear model for us into a variable called 3-way interaction. And JTools has a great summary function, so sum stands for summary, and it will print out the ANOVA table for us to read. So I'm going to press play. The first bit of code that you'll see tells you information about the model. So we have 44 observations, 25 of our 69 participants didn't complete the study. It confirms that our dependent variable is one that we want, and it says, yeah, we did a linear regression. Here's information about the model overall. The model is significant. The R squared, or the amount of variance explained by the model, is 0.36. So this model is explaining a lot, but we don't know about the individual predictors yet. So here's all of the individual predictors. Now, if you were doing this in SPSS, you would get a table which is the same thing. It would just say, like effects, and you would have the main effect of total price, the main effect of seller gender, the main effect of the moderator, and then you get the interactions. So the colons here represent interactions, and so the very last one here is the 3-way interaction. Now, when I look at this table, I see that the only thing significant is the intercept and told price, and so that would be, so you can really stop here. Because none of the interactions are significant, you can just go ahead and interpret that main effect of told price. That being said, let's imagine that the 3-way interaction was significant. What should you do then? Well, JTools has a function called probe interaction. And so you send probe interaction, the 3-way interaction variable that you created with the LM function. you tell it what the first predictor is, tell it what the second predictor is, or the moderator you want on the x-axis, and then you tell it what the third predictor is, which is in this case is going to be Q53.1, which is just a variable I picked from the data set. So what should happen in your project is, you're going to have your seller gender and told price as your first two independent variables, and then you're going to have the moderator that your group selected as your mod 2 here. You can set your alpha to 0.05, and when you run it, you get a ton of information. The best being, of course, this great graph that's automatically created. Now, what I like to do to interpret this is I'm going to hit preview. It's really hard to click through all of these tables and keep track of what's going on. So what I like to do is to have the graph on the left, and then on the right, I have my preview, and I go through the preview. So here's my three-way interaction. I'm probing the interaction, and here's how you can read it. So the first little box says, while Q53.1, so that's the second moderator, equals 3.07, and then you see it says -1 SD. So that's when this is for participants who are -1 standard deviation below the mean on your moderator. And we can look at the graph over here, and we can see, oh, that's this graph right here. So this information that we're looking at over here is describing this graph. And when I look at this graph, I see two lines, right? They're both going up, and my question would be, is the slope of this line significant, and is the slope of this line significant? Because they might be, or they might not be. We have to look at the test to see. And so here's where that information is on the right. So this says, this is the slope of seller gender effect code. So seller gender is on the x-axis here. It goes from -1 to 1, okay? So is the slope of seller gender effect code significant when told price effect code is -1? Okay, so told price effect code is the blue line, all right? We're in the -1 standard deviation chart for our moderator, and we want to know, is this blue line significant? And the answer is, it is not. What about the red line? The red line is when told price effect code equals 1. So that's right here. The slope of seller gender effect code when told price effect code equals 1. So from here to there, on that red line, is it significant? And the answer is no. I mean, obviously none of these are going to be significant because our three-way interaction was not significant, but that's fine. We're just going to go through and show you how to read these charts. The next box is when Q53.1 equals 4.57. This is average. So for participants who are average on the moderator, how do their scores look? And again, we see these two lines. And our question is just, are either of these lines significant? So for the told price effect code equals -1 line, which is the blue line, is that significant? No, it's not significant. What about for the red line? Is this significant? No, it's not significant. All right, what about for the final box? This is for when Q53.1 equals 6.07 or +1 standard deviations. So +1 standard deviations here. Is the blue line significant? That's told price effect code equals -1. No, it's not. Is the red line significant? It's actually going in the other direction. The answer is no. So none of these are significant. One thing I can say visually from this, though, one consistent effect seems to be that the levels of told price effect code differ, right? Blue is always much higher than red, and actually that is what the main effect of told price effect code means. The blue lines and the red lines are different from each other in terms of their, not their slope, but in terms of their height on this graph. And so that's all you need to do to run a three-way interaction in R. It's just those two lines, or let's say 3 lines. So those 2 lines, and then to probe the interaction, which I think most groups will not have to do, you will run this line. And the reason I say I don't think most groups will have to do it is just because the power in our samples is so small that I don't think that we'll have the power to detect significant 3-way interactions. But if you are in a group where that is the case, these are the steps you would follow. And I really think that the best way to analyze this data or to interpret the output is to have the graph on the left side and to walk through all of these tables step by step on the right side.